Here are your notes for today, section 6.1. Guess we're not really flipping them since you're not doing this outside of class, but it'll work. We're talking about similar polygons. You did get introduced to these last week when you did the exploring worksheet, section 6.1. If two polygons or more are similar, corresponding angles are congruent to each other. The corresponding angles are congruent, the ones that relate to each other. The corresponding sides are proportional. And proportional, we'll work with proportions in a moment as we talk about them. Scale factor is a word that was introduced to you on the last worksheet. The ratio of the lengths of two corresponding sides. The ratio of the lengths. So basically the fraction of the lengths. Scale factor, ratios, fractions, they are always reduced. In the reduced format. Add that to your notes. Make sure you write that on there. A similarity statement. You were asked to do a similarity statement in number 5 of last week's worksheet. We know that this is a quadrilateral. We don't know what kind of quadrilateral, but we know that it's a quadrilateral. Quadrilateral KLMN is similar to triangle PQRS. Take a look at that similar symbol. It's like the top of the congruent symbol, the swirl at the top. You take the equal sign out, that's similar. Difference between a similarity statement and a proportionality statement. A similarity statement has a similar symbol. A proportionality statement has proportions. Proportions, meaning two or more equal ratios. Two or more equal ratios is a proportion. So I'm going to take my first segment, or my first side, KL, and it's going to equate to PQ. Segment KL over segment PQ, or the measure of those. That'll be equal to whatever the length of segment LM is, and the length of segment QR. Your third side will be segment MN, which is in a direct relationship to segment RS. And then the fourth side, if you consider that a quadrilateral connects all the way around, you will have side KN will be similar to, or in an equal ratio to side PS. In a proportionality statement, all ratios are equal to each other. All ratios of the sides are equal to each other. If side KLMN, each side is twice as big as PQRS, then the whole quadrilateral will be twice as big, and all of these ratios would reduce to 2 to 1. If it's 3 times bigger, it'd be 3 to 1. If it's 3 over 2, they're all going to reduce because we reduce ratios. Here you have a diagram. It's on your handout already, asking what is the scale factor. Notice how they wrote it here of A to B. Same wording, A to B, whether you write it with a colon in between or write it as a ratio. A to B, meaning you have to know how big A is. How big is that quadrilateral? Well, I can't use X because I don't know how big it is. I can use 12. If I compare side 12 to side 8, in a reduced form, divide them both by 4, you're going to get a scale factor, if you divide them both by 4, a scale factor of 3 to 2. I could also use 9 and 6, since those are corresponding sides. If I did 9 to 6, those are both divisible by 3. 9 divided by 9 is 3. 6 divided by 3 is 2. Either way, you get a scale factor of 3 to 2, no matter which two sides you pick. So to answer the question, what is the scale factor of A to B? You have to say it is 3 to 2. And that way you know that quadrilateral A is bigger than quadrilateral B. If you reverse the order, B to A, then you have to reduce the scale, or reverse the fraction, the scale factor. If you reverse the order of the question, you have to reverse the order of the answer. Now it wants us to find X. That's where our proportionality statement comes in. It is a quadrilateral, but you don't need all 4 statements You don't need all 4 ratios. If you just work with 2 of them at a time, you have a proportion that you can solve by cross multiplying. So if I go back to here, find x, my x is in direct relation with the 4. X and 4 are corresponding sides. X comes from quadrilateral A, meaning its scale factor is 3 to the scale factor of B, which is 2. That gives you a proportion to solve. X over 4 equals 3 over 2. You could use 12 over 8, 9 over 6 as other ratios right there, but you might as well use a smaller, more reduced format. Solve this with cross multiplication. 2x, put an equal sign in between, cross multiply this way, equals 12. Divide by 2, divide by 2, x is 6. 6 over 4 equals 3 over 2. Some of you could very easily have done that in your head because it was an easy one, no decimals or fractions involved. You recognize maybe that since 4 is twice as big as 2, 6 is twice as big as 3. That's okay for now because it wasn't a decimal or a fraction. You won't be able to do them in your head later. Find y. We're going to use that same scale factor of 3 to 2. Let's see what y corresponds with. Y is in the same corresponding side as the 15. 15 is coming from quadrilateral A, which means 15 is going to be bigger. It's got to be on top. Y this time is in the denominator because it's from the smaller. Both fractions are set up as A to B, A to B, A to B. Cross multiply, or do this in your head. 3y equals 30. If you divide by 3 on both sides, you find out that y is 10, which again you could recognize 3 times 5 is 15, 2 times 5 is 10. It doesn't matter to me right now how you come up with the answer, as long as you know the process when the problems get more difficult. Next slide. Pause it if you need to go back and double check, make sure you have everything. Question is asking about scale factor again. Scale factor is just a reduced ratio. We've got a pool and a patio. Mine's colored, yours is not. The scale factor of the pool to the patio is the area surrounding it. The pool is 32 feet long. The patio, assuming that this is a full rectangle, is 48 feet long. That should actually have a label. They're all feet. 32 to 48. That's not the scale factor until you reduce it. Once you reduce this, both of those numbers are divisible by 16 or divisible by 4 twice. You're going to get 2 to 3. There's our scale factor of the pool to the patio, meaning the patio is bigger than the pool. The patio to the pool, without doing any of the math, you're going to reverse it. 3 to 2. And you could check your answer using 16 and 24. If you want to use 16 and 24 and use the widths of the patio and the pool, patio is 24, pool is 16. You've got 24 over 16. Both of those are divisible by 8. 24 divided by 8 is 3. 16 divided by 8 is 2. Format on the scale factor doesn't matter to me. You can write it as a fraction ratio or as a colon ratio. Either one of those are both fine, as long as they're reduced. The perimeters. Let's do it the long way. Find the perimeter of the pool. Perimeter of the pool. You've got to add up. 32 plus 16 plus 32 plus 16. You should get 96 feet all the way around. Perimeter of the patio. Go ahead and add that up. Double check my math. You've got 48 and 24 and 48 and 24. You're going to get a patio that has a perimeter of 144. What is the perimeter, the scale factor of the perimeters? If we go pool to patio, it'll be 96 over 144. 96 over 144. Believe it or not, both of those perimeters are divisible by the number 48. 96 divided by 48 is 2. 144 divided by 48 is 3. The scale factor of the perimeters is going to be exactly the same as the scale factor of the sides. So you no longer will have to work out the whole entire problem and find the perimeters. Sometimes they may not even give you enough information to do the perimeters. My face is all written on. Okay, you may not have enough information to do the perimeters. They may only tell you part of it or one side, or it may not be a perfect rectangle. If that's the case, if they're asking for scale factor perimeter, the scale factor of the sides and the scale factor of the perimeter will always match. Assuming the two, or knowing, not assuming, knowing that the two polygons you're working with are similar. They have to be similar for that to work. All right, let's take a look at the last two slides. What is the scale factor of the perimeters of the two quadrilaterals given here? We don't know. We don't know the perimeters. They did not give us enough information. We have no idea how big this base is of this trapezoid, how tall the trapezoid is, but what we just found out is the scale factor of two similar quadrilaterals. These are similar. Let me write that in there. Similar quadrilaterals is the same as the sides. The only two sides that we know that give us enough information is 15 and 6. What's the scale factor? 15 to 6. Divide them both by 3, and you get an final answer of 5 to 2. That's 5 times, and that's 2 times. Continue on this question. Find x. How do we find x? We take that similarity scale factor. We might as well use the reduced one, smaller numbers to work with. 5 is to 2 as 10 is to x. Again, for most of you, go ahead and do it in your head. Figure it out. Others of you, cross multiply. Both ways, 5x equals 20. Divide by 5, you find out x equals 4. There's your distance up there. Write the similarity statement. You got to be careful because one of them is reflected. This one's facing this way, this one reflected over that way. It's like our glide reflections with our tessellations. It's completely reversed. So make sure you line up the letters carefully. This J up in this upper left-hand corner is going to match with the R. There's a number of combinations of ways that you could do this. You could call this JKML, JLMK, KMLJ, as long as you go around in order. You cannot call this quadrilateral JMLK. That doesn't work. You have to go around in perfect succession. Okay? Write the similarity statement. Here would be an example. JKML is similar. There's that symbol. Similar to RSPQ. Make sure they match up. Your P has to be the same place as your M. Your S and K, your J and R, your Q and L. They all have to match. All right, last slide, the dilation. And again, you've already been introduced to this when you did explore and investigation. You should be familiar with the word dilation. A transformation that preserves, it maintains it, it keeps it. Keeps the angle measures. It keeps the angle measures. Go all the way back up to the first slide. Corresponding angles are congruent. They're not going to change size. It results in an image with lengths that are proportional. The sides are going to change. They're going to be proportional to the pre-image lengths. Sides will be proportional, the pre-image and the post-image. So you're going to take this. If I take triangle, if I take the blue triangle and I move it, see how angle F is congruent to itself? Angle E is going to be congruent to angle D. Angle G is going to be congruent to angle H. The angle measures are preserved. The lengths are proportional. Looks like we don't know how many are going to fit in there. Oops, we'll see how many go in there. Triangle FEG is similar to triangle FDH. Careful of the order. The order has to match. Describe the dilation that moves triangle FEG onto triangle FDH. You're taking the blue triangle, or the smaller triangle, and dilating it onto triangle FDH. In other words, it's going to get bigger. It's going to get bigger. Now be careful. You've got to look at the triangles. If you're looking carefully at the triangles, let me go back a step here. Okay, if you're looking carefully at the triangles, this triangle has a measure of 10 on its side. How long is this side of the triangle? It's not 15. That'd be the easy, fast, quick way to do it, but the wrong way to do it. You're looking at this and saying, this one is 10. Whoops, don't want to do that. This one is 10, and this triangle is 15. Not true. This triangle is 10, and this triangle is 25. You've got to add up both of those numbers. The length of side FH is 25. Describe the dilation that moves triangle FEG onto triangle FDH. We're going to take the number 10, compare it to the number 25, and describing the dilation is the same as a scale factor. Few different words for the same thing. 10 to 25, divide them both by 5, you get a 2 to 5. Describe the dilation, it'll go from 2 to 5, would describe that. That's your scale factor. And you know, because you're going from blue to red, it's going from small triangle to big triangle, so it has to be small number to big number. If they asked you to describe the dilation in the reverse order, triangle FDH onto triangle FEG, you would reverse it, 5 to 2, that it's shrinking. All right, use these notes. Ask any of your peers or anybody else to help if you're confused on any of it. Rewind it, watch it again, go through your book. I took most of this, or a lot of this, from your book, section 6.1, and get started on your assignment. 6.1, page 362, you have to do 3 and 4, 7 through 13, all 7 of those, 31 and 32. I have on here Explore Properties of Dilations worksheet. You may want to go back to last week's worksheet on 6.1 and double check some things. Other than the distance formula, which you had to look at in review from chapter 1, there were some dilation scale factors, similarity statements. Go back and double check worksheet 6.1 and make sure you completed it correctly now that you have the notes. These two will both be added into your notebook packet. That'll be turned in probably Monday next week. All right. Geometry flip notes for section 6.1.